Okay, we go on to problem number 9. We have x cubed minus 3x squared y plus 2xy squared is equal to 12. Again, we're going to have some basic product rules in here, and let's see how that works. Okay, so we set up, we're looking for the derivative of both sides with respect to x, and we're going to get, first term is very easy. The second term, don't forget, it's a product and there's a negative sign out front. Okay, so we have 1, which is 3x squared, times d2, which is y prime, plus 2, which is y, d1, which is 6x. So the derivative of 3x squared is 6x. Alright, so we have the second term. The third term is positive, so it's going to be a lot simpler. We have 1, which is 2x, and 2, which is y squared. So we want 1 d2. 1 is 2x, d2 is 2y y prime, plus 2, which is y squared, and d1. The derivative of 2x is just 2. And finally, the derivative of 12 is just 0. And so we're ready to start to simplify here. Again, remember, this is the calculus is done at this point, and the rest is just algebra. So be careful with it. So we need to apply that negative sign to the two terms inside. Both are going to become negative. Then we have 2x times 2y y prime. That's going to become 4xy y prime. And then plus 2y squared equals 0. Okay, how many y primes do we have? There are 2 of them, so we're going to move everything else over. When I move over for aesthetic purposes, I'm going to move over something that's negative if I have it first, and then move the positive terms over because they're going to become negative on the other side. So I move over the 6xy and it becomes positive, the 3x squared is negative, and the 2y squared becomes negative also. And that leaves me on the left side. I'm going to put the positive term first, 4xy y prime, and then minus 3x squared y prime. Does it have to be with a positive term first? No, but it's always easier to work with when you do have that. Alright, so we're going to next factor out the y prime from the left side, and we get y prime times 4xy minus 3x squared is equal to 6xy minus 3x squared minus 2y squared. We divide both sides by the 4xy minus 3x squared, and that's basically all there is to it. And you can see that you don't have any common factors in the numerator, in the denominator, and so we're all done. And that's problem number 9. Okay, with problem number 11, we come to the fun stuff. We come to trig functions. And we're just going to do exactly the same stuff, only this time using trig functions. Let's get started. Alright, even though the trig stuff is frightens us a little bit, but we know how to work with implicit differentiation, so we're not going to be scared of that. Alright, we take the derivative of the left side. The derivative of sine x is just cosine x. Now the derivative of 2 cosine 2y, which is a chain rule in itself, is going to be the derivative of, first of all, the 2 is a constant multiple, so it's going to be 2 times. The derivative of cosine is negative sine. Leave the inside alone, which is 2y. Then we're going to multiply that times the derivative of 2y, and the derivative of 2y is 2y prime. And the derivative of 1 is 0. Simplifying a bit. Now the minus sign that goes with the sign is going to come out. Be careful with all these 2's there. The inside 2y cannot be moved out, but the 2 times y prime and the 2 in the front over here, those two 2's can be multiplied together. And we get cosine x minus 4 sine of 2y times y prime equals 0. Again, we just want to isolate the y prime. So we move the cosine x over and it becomes negative. Negatives on both sides can be canceled. All I need to do now is divide both sides by 4 sine of 2y, and we're done. That's how easy it was. The trig problems were even easier than the algebra problems. Okay, so we have y prime is equal to cosine x over 4 sine of 2y. And we'll go on to number 13 in the next video.